Greetings, sir. This is Rohit Chaudhary, and along with my teammates Anubhav Gupta, Chintan Chawda, and Mamidala Shriram, we today have made our project on AFT survival regression on Hadoop Spark cluster, and today we are going to present the same. So, what is Hadoop? Hadoop is an open source framework for distributed storage and processing of large volumes of data. It provides a scalable and fault-tolerant platform for handling big data by dividing it into smaller chunks and distributing them across a cluster of computers. Hadoop consists of two main components, the Hadoop distributed file system and MapReduce. So what is Spark? Spark is an open source distributed computing system that is built for processing and analyzing big data. It provides an in-memory computing framework and allows for high-speed data processing. Spark supports various programming languages and offers libraries for machine learning, graph processing, stream processing, and more. What is AFT survival regression model? The AFT survival regression model is a statistical model that is analyzing time-to-time event data, particularly in survival analysis. The AFT model assumes that the logarithm of the survival allows for estimating the effects of covariates on the survival time. So now we are going to do Hadoop installation in our Ubuntu operating system. We first going to install JDK file on our system. As it is already installed, we are going to do ls and see whether it is there. As we can see, there is a Java 8 file in our system. Now we are going to do cd. We are going to clear everything. Now we are going to open the bash rc file, so sudo nano.bash rc. Now we are going to change all the we are going to comment out all the files here, export files here, and we are going to change our Hadoop version to 3.3.5 as that is our version. We will be saving this bash rc file and we will now be installing our SSH keys. Now we will be extracting our Hadoop file which we have downloaded beforehand. So we are just doing that. Now we are going into the directory of Hadoop, then etc. Now etc Hadoop. As we can see, all these files are in etc Hadoop. Now we are going to do Hadoop, then cd etc and Hadoop, and we are going to clear. So now we are in Hadoop etc Hadoop. We are going to give it the password. As we are seeing, it is Hadoop env.sh, and we change the export Java file there. Now we are going to open the core site through sudo nano, and we are going to change the configuration of this file. Same with HDFS site.xml. We are going to change the configurations here as the value is 3 there because of the name node and the clusters. Now we are going to change the MapRed site and its configurations. Same with the yarn files. This is the IP address. This is the IP address of the host. Now we are going to SSH localhost. Then we are going to generate a key. Then we are going to cat the command and give it to someone else, copy the command. We are going to authorize keys, and then we'll be formatting the name node as it is as it has been already done before, just showing the commands. Now we are going to export the SSH key and then start our Hadoop. So we are going to do start all.sh, and as we can see through localhost 9870. Here we can see that the data nodes are starting, name nodes are starting, resource managers are starting, node managers. Now if we connect our localhost here, we can see that the Hadoop has been installed. Greetings, sir. This is Anva Gupta, roll number 21BDS004, and I am setting up the Hadoop multi-node cluster here. So we go to the directory sudo nano etc host, and we paste the IP address of the node master and their slave nodes. Now we go SSH to know, and we run the following command to know the our SSH keys, and we pasted it into the authorized key along with the our slave nodes, the SSH keys of slave nodes and master nodes here. We come back to home directory and clear all the commands. Now we go to Hadoop etc Hadoop to configure the following files for the following configuration of Hadoop. Now we go to sudo nano core site XML, and here you can see we added a property, and here you can see node master 9000. It is our local host, and now we go the property of sudo nano yarn site XML, which is our resource manager. Now we have added the following properties here, and here you can see we have added the IP address of the master node here 10.0.10.94. Now we go HDFS site XML, and here we added the again following property, and here we can see the DFS replication, the value is 3 is just known as the number of slaves and masters. Now we do run this command and come to MapReduce, MapRed, and enter the following command. Now we go to the worker file where we can enter the localhost and about master of slave node and node 2 are just our slave nodes. Now we finally set up Hadoop environment where we do nothing just but export the Java home path. We come back to the home directory and go to the Hadoop bin Hadoop and format the name node format. This formatted the all the things. Now we are starting the Hadoop multi-node cluster. Start.sh. Greetings, myself Chintan Chavda, 21 videos 013, and I'll be guiding you through Spark installation and Spark clustering. So first, we will go to etc host where we will edit master and nodes IP addresses, and we will save the master IP address as node master and slave nodes as node 1 and node 2. Further, we will check for Java and Scala versions, and hence we can see they both are already downloaded in our system. Next, we will install OpenSSH server client, but only in the master node. So we'll copy the command and paste it in the terminal. It is already downloaded in the system. Next, we will generate the key pairs, but we will not run the command as it may disturb the configuration of already set up Hadoop cluster. Next, we will go to SSH and we will enter into the authorized keys where we can see that we have pasted the SSH keys of master and the other node. Now we will try connecting with the node 2 and we are successful. So we will exit and come back to the master node. We will go to the root directory. From here, we will go to user local bin. From here, we can see that the Spark is already set up in the user local. So we will come back to the home directory where we will enter into .bash RC file and we will set the path of Spark home. We will run the .bash RC file and we can see that Hadoop cluster is already set up from the previously ran command and it is showing two live nodes. Here it shows two active nodes. Now we will try adding a file folder into the Hadoop where named example, and when we come back to the web UI and go into the utilities and browse the file system, we can see the example is already added. Next, we will be entering into user local Spark for starting the Spark cluster. Now we will enter the command to start the Spark cluster, which is shown, and the process has been started. Going to the web UI, we will enter the node master 8080 and we can see them all both the worker nodes and their IP addresses and the Spark cluster has been complete.
Greetings, sir. Myself, Mamidala Sriram Sai Sandeep, roll number 21BDS034. Now I'm here to demonstrate running of Java algorithm on Spark cluster. Firstly, we will import the dependencies of Spark and Scala and select our algorithm which is AFT survival regression through Java. And now, as you can see, our Spark is currently disconnected and not running any process. So we cannot see any in output through it. As we run the algorithm, we can see our Spark shows the output. We can see DAG visualization, which shows our process. We can see additional metrics. We can see the event timeline, which shows whether our process is executed, stopped, or unsuccessful. As you can see now, if we re-execute the program, we can see the storage and other things, environment, jobs. We can see the timeline where it shows the green part shows our process has executed successfully. This show we can see the total jobs executed. We can see if our algorithm has failed or succeeded through the event timeline. We can see the number of active jobs and completed jobs. Now we get the final output of our algorithm through this table and the values are generated here. Now we are going to stop the Spark and Hadoop cluster. And before that, here in JPS, it shows that our algorithm is running on master. Now we are going to stop the Spark cluster first. As we can see, now we are disconnected from Spark, and now we'll start the Hadoop.